Hey. Oh well, I'll just have to do. Um, Hello. I see there's a few people out there for this stream as well. So thanks to you, those of you who could be here as always. This is Labor Day, but this is also just the time when I record the week's lecture. So you're always welcome to be here live, of course, and it will always be available in the various places. The recording. So thanks if you could be here. If you're watching later in the week, I hope you're having a good week. So we're finally starting to get into slightly more interesting things, um, and getting past the warm up. So if you need the refresher time in C++, um, you obviously do not need to wait until I give you an activity to do. You can go do your own activities, and I am trying to draw your attention to the features of C++ that we need soonest. So I mean, we need to be able to create a REPL, of course, doing inputs and outputs, declaring variables and initializing them, um, doing logic, doing loops. Today we'll do functions, and then we'll do structured data and classes in the next couple weeks. So if you feel like you're rusty on these things, obviously do not wait until I give you an activity to do. Go out and do your own activities. You can find lots of programming problems in the world. You can go back and take programming projects from your programming and algorithms one class and implement those in C++, which is one of the ways that I practice new languages, is by using my own assignments from my various classes. So hopefully you are doing that, and that you're fine. C++, there's a lot of the syntax can be complex. So you want to sort of be comfortable with the basics, so you can move on from there and start doing the interesting stuff. Okay, so where I thought I'd start is by showing a few examples from last week's labs, and these are the good ones. And these aren't all the good ones. I just kind of stopped at 5 that I'd quickly show you real quick. These are not classmates who are better than you or smarter than you or more experienced than you. Like as not, they just put more work into the lab than those of you who struggled with it did. I had nobody in this class come to office hours last week. I only had one person in this class Canvas inbox me with any questions, and I don't think, pardon me, I don't think I saw any Piazza messages asking for help. So if you are finding yourself rusty, no, I did have one person. I forgot. Yeah, I forgot I did meet with one person from this class in office hours. And then I had one person message me in a Canvas inbox. But that leaves a lot of other people who may or may not have had struggles who just didn't communicate them to anybody for any kind of help. I'm pretty sure that one person went and got help from Stack Overflow, which is the best way to get terrible programmers to help you in most cases, and it shows. So Stack Overflow might help you with a small little wrinkle in a language, but it's not a good place to go get solutions to things. Generally, you just see really crappy code on Stack Overflow. For some reason, the C language is very popular on Stack Overflow. Okay, so anyway, these are good ones, and I just want to show you some of the things that stick out about the better project. So this one, as an example, look at how nice the source code is formatted. So you get to, so you're inside a main, and everything in main starts tabbed over 1, because that's proper formatting of your source code. The random number generator is seated once at the top of main, like I did in the lecture last week. I wish more of you would watch that or would pull the code sample that actually contained those things in it. This person changed styles in terms of initializing variables, which is okay, but I'd prefer to use the one style. Other than that, though, just look at how this person's work is so polished. and it runs so polished as well. So it turns out that, in my experience, and I have a lot of it teaching at least, um, the source code and the output kind of all go together in terms of having a fine finished product. So the good programmers will do just that very thing. Here's another one. Also, this person used switches, so didn't just stick with what was in the samples, but tried something else, which is awesome. This person had their own style of setting up the logic, but the source code formatting, for the most part, is consistent and well done. Right, seated outside of the loop. There is one variable that's uninitialized, but they probably got a comment about that. But generally, if you just look through here, you'll notice there's not big clumps of blank lines. Everything sort of seems to follow a certain use of the curly braces and a certain tabbing over, and that's the kind of work that we would like to make in this class. Here's another one, kind of same idea. This person used functions, which was cool. I thought I'd show off that some people kind of pressed ahead and tried out using functions. Generally speaking, this one is well formatted as well and consistently formatted. So that was good. Here's another one that is nicely formatted and consistently formatted. That's just clean work. It's clean, good work. There's no extra blank lines. There's no like weird changing the way that variables are declared or the curly braces are used. That's just good, clean, competent work, which is what we would all like to be doing. Here's another one that ran well. So this one is using a few extra blank lines that are needed, but it was a good one for running. And then I'll just run one. So for those of you who struggled with this part, so there's the prompt. It's a nice clean prompt, by the way, where the cursor is sitting at the end of the line. That's not a requirement, but in this case, it certainly looks good than just sort of having a cursor down lower on the screen. So I'll play. I like the way that this person took the trouble to line things up. So you picked, lined up with computer picked, and then a result, and that all looks really pretty. I suspect if I put a capital Y, this works. It does. Not everybody was case insensitive about that, but if a capital Y works and a small y doesn't, or vice versa in your code, that's a detail that you want to clean up. Here's how I tested them, by the way. I did 6 rounds. I did 2 rounds of 1, 2, 3, 1, 2, 3. Notice, by the way, how the output has this extra blank line between the rounds. That kind of detail matters. That's the difference between having people who want to have you on their team as a programmer and people who don't. So this person, I would like to have the kind of person who pays attention to the details like this on my team. And then I'll say no, and then we get the results. So anyway, just some examples. And you'll notice sort of the general pattern is that the source code is decently formatted. I ran one just so you can see that those also stood out because the quality of their outputs was good. The programs worked correctly, all those things. So if you're struggling in any aspect, sooner than later is the time to reach out for help. And for me, not on Sunday afternoon, if you remember from the week 0 quiz, I'm not reliable for checking Canvas inbox on Saturday and Sunday. That's my weekend. So I will usually check once or twice, but I don't make any promises about that. So, yeah, make use of those outlets for help. Piazza, your classmates are generally very fast about answering, and they answer well, in my experience. Canvas inbox. So if you're not taking advantage, which very few of you are, of the extra assistance, please do so if you're having any struggle. And I got one project that was submitted in the C language, which is a 0 because we don't work in C in this class, and the assignments are very clear that this is C++. So My guess is Stack Overflow told the person to work in the C language, so they did, but Programming and Algorithms 2 at Butte College tells you to work in C++, so that's what we do in here. Okay. So anyway, there's a lot of really good ones. There are some people who just, I pinged you for some small issues like your source code formatting, maybe failing to initialize a variable, not being case insensitive, not doing the documentation. These things are all written into the spec. I took the time to write them into the instructions. I took the time to write them into the scoring rubric. So if you're missing points, hopefully I gave you notes that point you to where you can do your cleanup, because I want you to exit this class with your code and your output working good and looking good and being something that we can all be proud of. Okay, so I'm on the course homepage. Same as always, where to get me and your classmates if you need help. We'll look at week 3 and then we'll do some, what was my agenda look like? Yeah, we'll talk about functions and how does the unit testing framework work. So we're going to start unit testing this week, so we'll talk about that. And then I'll look at project 1 before I stop for the day. But first, let's look through the module just to get a handle on what's going on this week. Okay, so C++. So we'll create a replit for the third lab. We will implement functions in C++ to get ourselves up to speed on that. And then we will apply a unit test. So I'm actually going to cook up a unit test from scratch so you see how those are built, and you have a sense of how to interact with them. And then the readings. So a bunch of stuff on functions, a sort of generalized reading from Wikipedia on what unit testing is. Most of the rest of the semester, I will be using unit tests to evaluate your coding efforts. This is because you're going to write code at larger and larger scales, and it helps you figure out if you're doing the algorithms correctly, and it helps me evaluate your functionality more quickly if I use unit testing. So getting through the lab 2s, just as an example this morning, took quite a while because I was trying to sort of be careful and pay attention to the detail of your code. And our goal is that you are paying more attention to the quality of your work than I am, because it's your name on it, not mine. Although, and to a certain extent, my reputation is attached to your code when you lead this class. Okay, and then the doc test framework. In fact, I'm going to pop that one open so I can come back to it and show you how we build unit tests. Okay, so the lab this week is going to require an extra file. So it has a template, and then it has this .h file, this header file, that will have to be present for you to complete your lab. So what should happen at the end of this week is you click run, and your output is a report of the unit test, and then I will come in next Monday and I will click run, and my output will be a result of your unit test as well. And then there's some screen captures down here that show you what it looks like when you aren't passing all the unit tests, when you're failing some unit tests, and then a screenshot when you are passing all of the unit tests. Those aren't from Replit, but they'll look roughly the same. This week, the Piazza discussion, I think some people have already been in there, so that's just so it doesn't become too big of a grind before we get into sort of going deeper into some of our content. Just a short break on the Piazza thing, just to sort of keep alive activity, meaning you go in and just say, I'm still here, hey, and participate. It's an easy one. And then we have the individual project, which I think I'm going to pop open as well, so I come back to that before we're done today. Yeah. Okay. So let me bring up REPL and create a REPL and talk about functions. Since this is Programming Algorithms 2, the expectation is that you know what a function is, you know what it means for a function to return a value, and you know what parameters to a function look like. In C++, as opposed to Go, there are a couple of additional options for creating functions. One of them we'll look at today, and another one we will put off for later in the semester. So for those of you coming from Go, the formatting might look a little bit different, but everything will hopefully be familiar to you up to the point where we talk about the difference between pass by value and pass by reference. So let me create a REPL. C++. I still get a few labs that the person just doesn't care enough to name it something. And that's fine, but if you don't care about your work, why would any of the rest of us care about your work? Why? I don't know. So you got to remember that programmers are humans, and you're going to be working with other humans someday. And generally, people are looking to work with people who try, who care about the details, who present themselves well. And by presenting themselves well, I mean do things like, hey, I went to the trouble to name this thing according to its purpose, as opposed to some random name, because I don't care. No one wants to work with a I don't care kind of programmer. So notice that I did it. Why? Because I care. Turns out it'll make my life easier later because I will be able to find it. So I sort of get on everyone's case about this early on. Some of you already have good habits, and please keep them, and we'll use them as an example for your classmates who hopefully will sort of take the examples they see of the good work and decide that they want to do polished work like that as well. These things do matter. Someday it will matter. So anyway, please keep that in mind. Okay, so let's do functions first. And there's a lot of gory details in C++, so we'll just do all of them. I'm going to change this out to use my style. Generally speaking, I don't put spaces between the includes. So if I have more than one include up here, I don't put spaces. I clump the includes together and I alphabetize them. I said this last week, by the way. I alphabetize them based on what's being included. So if I were to include C math, then I would put the include for that above IO stream, because the C comes before the I, and I do that. I also don't use more than one blank line. But I also kind of use natural groupings. The includes are a natural grouping. The using directives are a natural grouping. And the other thing you'll see is whenever I open up a block, everything inside of it starts one tab over. Everything. And if I open up a block inside of a block, then everything inside of it starts one thing over. That's just proper source code formatting style, and that's another one of those things where you want to be in the habit where you don't even think about it. Because if you have to think about that kind of thing, then you have to spend brain power on that kind of cleanup just so that other people will want to work with you and your code. And you will have less brain power left over for the interesting parts of our work. Okay, so let's... I don't like it that they don't have a return statement on there. So notice though it's tabbed over 1. This is the same, by the way, in every language in the universe except for a couple of weird experimental languages that are purposely trying to be hard to read and weird. Languages that we would use in production software have source code formatting standards that they use. They have a certain way of naming things. They have a certain place where they put the curly braces, lining things up. Those aren't arbitrary. Those are things that everybody does. And that's because it makes everybody's life easier to do that. I don't know why the focus is going in and out. I don't see it on my screen, so... Oh, good morning, Magenta. I don't know why the focus is going in and out. It might be a network thing. So hopefully that stops. Okay, so let's do functions. So anyway, yeah, I've sort of gone on and on about how the details matter and how the style matters, because it's important, and you will find that it's important to you at some point. So I'm trying to just get you in the habit in this class of thinking of it as important and it being just automatic, just automatic. So you're not newbie programmers, and your code can and should look like you know what you're doing. Okay, so let's do the most basic of functions, which is a function that returns no values, which in C++ we use the keyword void. So if you're coming from Go, functions that return no values don't have to have an indicator on them. You just say func say hello, and then you do the body of the function in Go, right? But in C++, where that keyword func is in Go is where we actually put the return type, the indicator. And for functions that don't return things, we use the keyword void. This concept is one of the most difficult for most of us, myself included, in learning programming. What does it mean for a function to return a value is very difficult to understand. And I wish there were some easy magic way to share with you the way that we all get past the point where we go from not understanding it to where we do understand it. It's just a difficult concept. But one of the things to look for in a function that returns a value is that it has a statement in it that includes the keyword return. So if there is a function that has the keyword return in it, then it probably returns a value. In this case, it's returning an integer. So you'll notice on main, which is a function, the indicator, it indicates that a integer type value is returned. So we would expect to find a statement, at least one, that says return, and then it's followed by an integer, either a literal integer or an integer variable. In this case, it's a literal. So in a function with a void return type, most of us would not put a return statement of any kind in there, because these things don't return values. They're not super useful as functions generally, by the way. Void returning functions are not the most useful of things in many cases. But and this concept is just hard to understand. That a void function, you just call it and something happens and then you go on about your business. I'm trying to think of an example in the real world that sort of interacting with a business, let's say, is like a void function. Because if I go to a coffee shop, they return coffee, right? So Starbucks is a function that returns coffee. So I give them money, that's my parameter or my argument, and they return to me coffee. Who doesn't? If I go to the car wash, I give them my car as input, and they return a clean car as output. The one example I can think of, and I don't have kids, but for those of you who have kids, or those of us who don't but can imagine, if you send your child to their room and say, clean your room, and that's the end of it, I don't want to hear about it. That's kind of a void returning function. Clean room. So you don't want them to come report back later and say, yes, it's true, I cleaned my room, or I cleaned my room to a quality of 8 out of 10 or whatever. Just void clean room, meaning go clean your room, and I don't want to hear about it. That would be the best I can come up with off the top of my head. Anyway, so we'll implement one though. So a say hello function, which would just be hello, is a void function. It takes no parameters. meaning when I call it, I don't provide any additional data that it can use to produce its result. So in this case, if I want to use the function, I would just call the function, say hello. I would expect to get no information back from it that it computed or produced. I just say hello, something's going to happen, and then I go on about my day. All right, so that's the most basic of functions. If you're in doubt, by the way, when you are creating a function, or I've instructed you that you should create a function for something, you can always start with a void function that takes no parameters and then make adjustments later as the need arises. And I'll show you an example of that in just a second. Okay, so here's the basic setup, and I'm going to now alter it a little bit and begin using the style that I prefer for these things. So before you can call a function, which I have done here in main, I am causing this function to execute. Before you can do that, C++ needs to know that the function exists. And there's two ways of doing that. So one way is what I've done, which is to define the function. And a function definition is all of it. It's the return type, it's the name, it's the parameter list, and it is the block with the executable code inside. That is a function definition. So that is one way to tell C++, hey, the say hello function exists and this is what it does. But it turns out that you don't have to give C++ everything for it to let you do this. You can put the definition of the function below where you want to call it, and then before you call it, you put what's called a function header, which is also a declaration. So you can declare, or what I usually say is put a function header. You can declare a function. Notice there's no block, there's just a semicolon. So a function header or declaration is the return type, the name, and the parameter list. So if you give C++ the function header, it will then allow you to call that function, and you can give it the full definition of the function later. Now this is the style that I prefer, especially when I'm teaching, because it lends itself well to something that we're going to do in the very near future. All right, so that's the most basic kind of function with a header and a declaration. So now let's do a function. Say hello to person, which in this case I want a string parameter, which is the person. And then I can do CL. Oh, what am I doing? We just want headers. Notice, by the way, I am taking the time to update my documentation. I'm being careful about my formatting, my spacing. I am trying to make it as readable as I can for your purposes, but I am taking the time to make my code presentable, because other people are going to look at it and are looking at it. So here's the second function. I've only done the header, which means I've done the return type, which this is a non-returning or a void returning function called say hello to person, that now requires that I offer it, when I call it, a string representing the person I want to say hello to. And then I will go down here and I will define it. So I'm going to fold up the say hello function. When I define functions, I put them in the same order that I put the headers in, which just I find makes my life easier when it comes to navigating. So if the header comes second, then the definition comes second. So now the full definition of say hello to person, string person. And we will do hello person, period, new line. So there's the full definition of it. If you give me a string that has a person's name in it, I will say hello to that person on the screen. I won't return any data. I'll just say hello to them. And then now that I have a full header, I can call it, and a full definition will tell C++ what to do with it. So now in main, which is where the program will begin executing. So this is where I'll sort of use the control point for accessing and firing off my functions. I'll still keep the say hello, which just is hello, and then I will fire off my function say hello to person, which requires this one parameter. So it should say hello, comma, space, void, period, and then new line. Oh, except for I forgot to include string to make that happen. So include string, and notice I put string after IOStream because that keeps them alphabetized, and then I will put using standard string here, and then everything will work again. I noticed in the errors at the bottom, if you can see them, they're all about standard string, so it occurred to me immediately I didn't have access to that in my program. Okay. So there's hello and hello void. Now I notice that hello without a period at the end looks cruddy, so I'm going to go fix that. Hello, period, which is more consistent with the hello person output, so I thought that was a better idea. Okay, now let's do a returning function, and then a returning function with parameters, and then a couple of other things as examples of functions before we talk about unit tests. So I'm going to fold. By the way, I notice, oh no, it's on the edge. Okay, everything's good. I'm kind of just looking at the way things are lined up. So I separate the function definitions with the space because it's so much more readable if you do that, and that's, I suspect the majority of programmers use that style. Again, because they don't want the people they work with to hate them and not want to work with them for the mess that they give them. So that's on purpose. Okay, so let's do another kind of function. So this time we will do a function that returns, let's say, an integer. And I will call it get secret number, no parameters. So I did the header for the function, which is the return type, the name of the function, the parameter list, which is empty for this function. Now I will go do the definition of it. And notice I'm using the same spacing throughout. So I don't space between the function name and the parameter list. I do space before the opening curly brace. And that's a common style. All right, so get secret number. Because it has an int here and not a void, I would expect to find a return statement that has an integer in it. This time, actually, I'm going to declare a variable. I'm going to call it secret number. And I'm going to initialize it. And then I'm going to return the secret number just to show you that you can, in fact, have a function that creates variables, alters variables. In fact, let's make it 41 and then increment it. And then return the result of incrementing it. So this return, secret number, is here because of this return on the function header. So the function says, call me, you get an integer back. So the function needs to return an integer at some point. In this case, it's an integer variable, and that's fine. You can return integer variables. You can return variables that you have altered in the course of executing the function. As long as you return a thing that matches what the function says it returns, then all is good. All right, so there's get secret number. I'm going to call it. It's going to run, and I'm doing this slightly kind of dumb on purpose. So hopefully what I just did, some of you will think to yourselves, something's wrong here. Even if you think just that much, like something doesn't feel right. And what doesn't feel right is that I called get secret number, but never did anything with it. All right, so what happened to secret number? Well, what happened is I called it and then never made use of it. So why would I call this function that's going to return an integer to me if I have no intention of using the integer? So what I need to do is capture it. And the way I'm going to do that is here in main, I'm going to say, well, I need my own variable. And I'm going to assign it the value that the function get secret number returns to me. Now, the way I like to initialize variables is with the constructor style, and I do this for all variable types. So int number will be initialized to the value that it receives as a return by calling get secret number. So if I look at get secret number, I'll figure out, oh, 41 is incremented to 42 and returned. So number will be that 42 that it gets, that we get from calling get secret number, and then I can do something like print it out. And to be consistent with the way I formatted all my outputs, I'm going to put a period at the end. All right, so the number is 42. Hopefully you can see that at the bottom. So there is a function that returns a value, takes no parameters. Let's do another one. All right, so here's another function. What it's going to do is it's going to test this number n. It's okay for your parameters to have single character identifiers as long as it makes some kind of sense. If a person reading it could think to themselves, well, what is that n probably? It's probably the number we're checking to see if it's even. Most of us could kind of put those pieces together. But when in doubt, give the parameter a full name, and that way everybody knows for sure what it means. Oh, is this number even? True or false? So there's the header. This function will return true or false. It's called isEven, and it requires that I supply it with a number. So let's go define it. So bool is even, int number. And there's a few ways that you can implement this. So I'll implement it 3 different ways, just so you can see how I get to the way I would actually do it. So I can do this. I can say, in fact, I'll do it 4 different ways. So I will say, no, let's just do 3. If number mod 2 equals 0, well, that is an even number. Notice, by the way, I always use the curly braces, even if I'm in a situation where I don't necessarily have to. I just feel like that eliminates an entire class of potential problems. That is an even number, right? Return true. Else, return false. So here's one way I could implement it. I just use mod 2. If I get no remainder back, that's an even number. And I'll go ahead and try it. Up here in main, I will go ahead and say if is even number equals true, and I'm going to refactor this in a moment. Else so here I'm in main, and I'm going to use the result of is even for part of main's own work. So if is even with the number that I got from secret number to see all the pieces coming together, if that returns true, which I can establish by seeing if it's equivalent to true, then I'll say and it is even. Otherwise, If this returns false, it'll say it is an odd number. So this one's going to say, and it is even. So now let's refactor and simplify the code a little bit. So one thing we can do to make this function just a little bit simpler is realize that the moment the function encounters a return statement, nothing else happens. So if the number is even, it's going to find itself in this if, it's going to return true and completely short circuit whatever should happen in the function. Because that's the case, I can actually take advantage of that to simplify my function and get rid of the else and just put a return false down here. So the return false means if I didn't manage to return true, then I'm going to return false. It's less code to look at. It's less logic to screw up. It's less curly braces to mess up and look at. The only way I can return false is if I don't return true. Well, that's basically the same thing, but yet with slightly different looking code. So, and it is even, and I would even go one step further than that in this case, which is the whole function really is just this test right here. This is either true on an even number or it is false. So I can simply just cut out all the logic and just return that expression. So I can get rid of the if and the potential if else and just say return the result of this comparison. If it's true that number mod 2 equals 0, then it's true the number is even. If it's false that the number mod 2 equals 0, then it's false that the number is even. And I don't even have to have the extra logic on the screen to look at. So this is the style I prefer. If I can have less code to look at and less code to mess up or maintain, the better. This is a balancing act. So sometimes a little bit more code can be helpful with a complicated algorithm. But most programmers would look at this line of code and realize, oh, they want to know if the number is evenly divisible by 2. That's all they're doing. And if it is, then that's an even number. All right, so most programmers would look at that and easily figure it out. I can also refactor what I'm doing with it in main, by the way, because the equals true is implied. So I don't have to have the equals true. I can just use the implied true to get the same result. And that's also, I believe, how most programmers would probably write it. That's how I would write it. And I would even argue this reads better. If is even number. If the number is even, print out it's even. As opposed to if is even number equals true. The meaning's the same. This one is actually slightly easier to read as normal language. Yeah, so Magenta asks, because we're talking about a bool in here, then all you need to do is test it as a statement itself, and that is true, yes. Which is cool and also just a little bit cleaner, and I think kind of reads as normal language actually better this way. Okay, so there is kind of the 4 most common, sort of when we're teaching it, kinds of functions. We're going to add one more today, and then one more. We might look at a couple of different ways beyond this, but for today we're going to add one more type before we call it a day, because you are going to see this in your lab. So let's go ahead and add one more way in C++ of setting up a function. There is in the Go language something that's roughly equivalent to this, so you'll see a familiar symbol. But if you're coming from the Go language, I would recommend just sort of think of this as a brand new thing to learn, and it's not a super hard thing to learn, but it is a brand new thing to learn. Okay, so let's see. Yeah, let's do it as a Let me do a simpler one first. Let's do a simple one, and then we'll do the hard one. Okay. So what I'm about to do is bad style for teaching purposes. So I'm actually going to name it with something like, so I'm going to say void is bad function. Not that, just the header. Okay, so I'm about to do bad. Let me fold up some of this stuff. I didn't fold all that I wanted. Can I fold all of it? There we go. All right, so I'm gonna, let me fold up everything. Okay, so I'm about to do a bad function for the purposes of teaching, and then I'll do an example that's a little bit more realistic in terms of when we would do what I'm about to do. Okay, so here's a bad function. Takes an integer. I'm just calling n, which is already probably a warning sign that maybe something not the best is about to happen. Is bad function int n. So this is a void returning function. So I'm not going to have a return statement, which is already kind of iffy. But I'm going to take this n, and I'm going to make it be -1. And then I'm going to say, print out what n is, which should be -1. So let's try it real quick. So is bad function, and I'll just say 10, 99. And then I'll call bad function, and let's see what happens. All right, so is bad function n equals -1. So here's the concept. When we call a function like this and pass it a parameter, this is a pass by value parameter. What that means is that the function receives a copy, the value itself. So the function is bad function receives a copy of whatever the original value was. In fact, let's give it 42, which is our number variable, just to show you that it doesn't change anything. It's still -1 in the function. But what the function is actually receiving is not the number variable itself, but its value. So the function receives n as the value 42 and then makes it be -1. I mean, if we want to be more convinced of that, let's just decrement that n so that we'll see that the function takes the value 42, which is a copy of the original, knocks 1 off of it, and should print 41. So now the function says that n is 41. Notice that I called it n. I can call it number if I want to. That doesn't actually have any real effect. The function calls the integer number, and so does main. But it turns out that isBad function only has a copy of that thing. So the way to prove that is after isBad function, say in main, number equals number. Number equals. So you'll see at the bottom that isBad function takes its copy of that number, which is its value, knocks 1 off of it, and prints out the decremented value that it just received a copy of. So that's called pass by value, which is the default in C++. It's also the default in the Go language. What that means is that the functions receive basically their own copy of the variable, but just its value. And the function can do whatever it wants to with that variable without affecting the original, because the function is only actually getting a copy. You can't see the copy being made. And the only way that you know a copy is being made is by looking at the function's parameter list. So if the function has a normal looking parameter list, that means that the function is requesting and receiving only a copy. And it can do whatever it wants to the copy without ever affecting the original variable, which is why in main it remains 42, because the isBad function is actually using the copy of this number, not the original. So Magenta asks, is that because the scope of the function doesn't change the variable itself? It's not. So the way I would describe it is, by default, without any help, a C++ parameter is a pass-by-value parameter, which means that, and I'll use the word scope, and maybe that will help Magenta. In the scope of the function, this integer number is a copy. It lives and dies with the function itself. So isBad function has a variable that it calls number that is a copy of the variable that main is calling number, but they're not the same variable. So you're right that this int number is limited in scope to the function. That's true. And because this number is limited in scope to this function, whatever this function does to this int number variable stays, sort of what happens in the function stays in the function. Okay, so now we're gonna, so there's two ways. Yeah, so Magenta asks, well, how do I get the function to make the alteration and be capturable by main? And yes, you would alter the function to return the value, which would be the proper way to do it, yes. But there is a way to pierce that boundary, and it's based on what the function sets itself up to do. So we're going to change that by changing the argument in the function to be a pass-by-reference parameter. So the ampersand changes the parameter to be a pass-by-reference. So simply adding this ampersand in on the function side of things means that the function will no longer generate a copy. It will actually reach back through and work on the original. So now this parameter is scoped to the calling function, not the function being called. You also have to change the definition, so we make sure that the parameter is a pass-by-reference on both sides. And now the function is saying, if you pass an integer in here, I'm changing it, not a copy, the original. So what we'll see now is main and the bad function both have the altered number, because this ampersand changes the entire dynamic of the thing. This is now a pass-by-reference. So what's weird is that the function decides whether or not it receives a copy or a reference, not the caller, the function. So it's the caller who has to be careful and understand that if I give that function a variable, it could change it. Now, it's also true, by the way, that you can't call the number with anything but a variable anymore. So if I try to pass just literal data, that won't work because this thing needs a reference to a variable, not to literal data. Okay, so that's a bad function because, as Magenta points out, if you want a function that takes an integer and adjusts it, what you should do is take a pass-by-value, alter it, and return the updated number. And I'll try to make a brief argument as to why. So let's do the good function. And really, we can just say return. So remember now, this is a copy. So anything we do in here is just happening to this locally scoped variable, but we can return the value we receive less 1, and this does not alter the original unless the caller wants it to be altered. So here's the good function, and now let's, often when I'm teaching, I'll put parentheses around here so you can see that's kind of what we want to return is the end result of knocking 1 off the number. So now let's see how the caller would use the good function. Let's get rid of the bad function. And now let's use the good function. So what I would do is I would say, for example, int new number is the result of passing the old number to the function. And I would argue that generally this is better style because you don't lose data. You gain sort of new information off of it. But if you wanted to, you could still say, well, I actually do want to overwrite the original. Let me put the space in here so that it looks the same. You could if you wanted to, but the whole point of why 1 is a bad function is because as a general rule, you don't like functions that go alter data out from under you when you're calling it. It would be like giving the DMV a copy of your birth certificate and they take it in the back room and they alter it and then they return it to you as the original. You don't want that, right? What you want at the DMV is, here's a copy of my birth certificate. If you screw it up, I would rather you not do that, but I will get the altered copy back from you, and now I have the ability to choose if I want to keep the altered copy or keep the original separate from the altered. Kind of the same concept in programming. The function is there to provide a service. And whoever calls the function should have some choice about how they access the service that the function provides. I know that sounds kind of weird probably because you don't think of the functions you write as part of your programming as being separate from your program. But I find it's very helpful to think this way. When I create a function for my use in my own program, it's still helpful for me to think about creating that function for future me to use. So I want to create that function so that future me has the best chance of getting the best result by using past me's function for help, which I know just one of the ways that I look at programming. But I'm also kind of suggesting that, kind of go through a process of coming up with a way that you tell this story in your head can be very helpful. But when you're writing functions, just sort of think that someday some other person might use my function, and how can I make it work best for them? Not take their arguments and make all sorts of alterations in their data and then say, good luck, other programmer. But think about how this function can be of service to another programmer and would function in a way that gives them control over their own data when they call your function. All right, so there's a bad one and a good one. And then an example of kind of using the bad one and the good one. So those are mostly garbage, but they're clearly labeled. So how am I on time? I think I'm doing okay on time yet. Whoops. Okay, so Magenta makes a good point. You always favor, if you need to create new data, that you return that new data to the person who called your function. But sometimes it is a matter of convenience that you want a function to do more than one kind of work at one time. So I'm going to make one up a little bit, but let's just say for argument's sake that you have a function that is going to compute a total bill on a amount owed, and a percentage of how much you want to tip. But then you also want the function not only to return the actual bill total, but you want the function to also return how much you're going to tip. Now you could write this in two functions, and you could make a good argument that you should write one function to compute the amount of the tip and a second function to take the amount of the tip and the total owed and compute the total bill. But let's just say for argument's sake that you've made the choice to design a function that's going to do everything in one place. So you want to return the total amount owed, starting with the total owed, the percentage of the tip they want, but then you also want to know the total tip. So in this case, since there's not a quick and easy way to return both the total amount of the tip and the total amount to be paid separately, one thing you can do is you can take advantage of this pass by reference idea and say to the person who calls your function, you're going to have to give me the total amount you owe, the percentage of the tip you want to pay, and then a variable that will allow me to alter it and give you the total amount of tip I compute for you. And then I will also at the end return to you the total bill that you owe overall, which would be the total owed plus the tip. So there are times when we take advantage of pass by reference to get more than one calculation sort of squeezed into a function. You're going to see that in the lab this week. All right, so there's the function header. And then I'm going to go do a definition of it. I'm going to assume that percentage tip is coming in between 0 and 1. So like 0.15 would be a 15% tip. So I'm actually going to use the total tip here, the one that has been provided to me by reference, which means that any alteration I make to it in this function affects the original. The total tip is the total owed times the percentage they want to pay. That gives me the total tip, and then I can return the total originally owed plus the total tip, so that I'm actually doing two things in one function. I'm computing the total tip, which they will get back from their by reference parameter, and then I return to them the total bill that they owe using the return statement, which is two doubles added together to give them the double result. So now let's go use it. So double total I owe, and then I will say, what did I call it? Compute total bill. So I'm going to need total I owe is compute total owed. And the first two values, since they're by, the first two parameters, since they're by value, means I can put literals there. So I'll just say I owed, I don't know, like $19.99. I can just hard code in, because that's an also by value, but then the by reference one, I have to provide the variable for this to work. This will not be formatted, so just heads up. So there's an example that's a little bit more realistic. I need the return value to initialize this total IO variable, but the function is also going to let me keep track of the total tip, so that I can afterwards say So that when the function's over, I actually have two pieces of information that have been calculated for me. The total I owe and the total amount that I ended up paying in tip. I could use that as a rough kind of error check here as well. Except for I called it total. What's it called? Total owed. I changed the name. Total owed? What's it called? Total bill. When in doubt, by the way, just go to the header, grab it, and then find where you misused it, which I did twice. So it's not formatted double output, but that looks, yeah, that looks roughly right. So anyway, the point really was to show you a function that was a little bit more realistic in terms of when would I bother myself to use this pass by reference thing. Okay, so I'm going to set this aside and I'll upload it as a sample so that I can wipe all of this stuff out. All right, I got to start being mindful of the time, but that was the bigger part of the stuff. So I'm about to show you unit testing, and I'm going to build one before I actually show you the lab quickly so that you can get a sense of how they work. So the concept of unit testing is that you can sort of automate the process of checking your code to see if it functions properly. So that's what we're using it for in our class. I give you an assignment from here on out pretty much. You implement the assignment per the specification, and then I run a unit test which actually tests your code to see if it produces the expected results. It's something that you want to know how to do in the world that we're living in. It's a lot of people have really embraced the idea of writing tests like this for their code, because it is one way to sort of add some assurance that the code functions properly before you've actually ever used it in a production system. All right, so let me wipe this out. And then let me go cheat a little bit. And grab the lab 3 code and then kind of strip it out and use it. Well, so Magenta asked, does the unit test the output for each section? So what the unit test will do is actually, it will be written against your functions. So the unit test will run your functions and then compare what the unit test expects for results from your function against what the results from your function actually were. And I'll show you how that works by writing some from scratch here. So it's going to test your functions, basically, to see if they do the work as intended. So let me get rid of all of this. Get rid of all of that. Get rid of all of this except for this. Okay, so this will be our basic setup. We're going to use a unit testing library called doctest. There are other unit testing libraries out there. There are a lot of them. Google, for example, has a very elaborate one called Gmock. There's a lot. I have chosen doctest because I think it is relatively simple. I like it for teaching people how unit tests work and how to write them for themselves. And I also like it that we only need one file to get the doctest library to work. So we don't have to do any kind of complicated installations for this particular framework. So to use it, you're going to create a new file in your REPL. You're going to call it doctest dot h to match this include exactly. Yes. Did it do it or not do it? It didn't do it. I guess what? There we go. I had to hit enter. So you're going to make this new file, and then if you're in the project, you will see that there's a link to doctest.h. So you will also go grab this file. It's a big one. So you'll do the whole copy and paste thing into your REPL, into doctest.h. So it's 7,000 lines of code. You never have to touch any of it. You just need it there for the rest of this stuff to work. So I like doctest because in one file you get all of its functionality. Okay, so the other thing you're going to notice here is this line at the top, doctest config implement with main. So we do not need an int main in our lab when we use doctest, because doctest actually does the main function for us. For this week, you will have functions that you need to complete. We'll look at it before I stop talking. But it's going to be built off of this kind of setup. So typically what you will find in a doc test, in a unit test, is functions, either here or in another file or other files. But the way we'll start to use it is to write tests against functions. But you don't actually have to write tests against functions. You can write tests just about stuff. So we'll say just set up a test case, and then I just tabbed over one, and we will do a check equals, and we'll just say does 0 equal 0, and then run it. So a lot of stuff happens behind the scenes when I run this, because doctest is going to step in and do a whole bunch of work for me, but I have just written a little test. All I'm doing is checking to see if 0 is equivalent to 0, and I'm going to see what the result of that test looks like. It's taking a while because doctest is not trivial to compile. So there you go. I have one test. I passed it. So I have a success. So all green means all good. So it turns out that 0 is equivalent to 0. If I try check equal 0 to 1 and run it, it's going to go through the same, kind of takes a little bit process. Now I'm failing one. And you want to learn how to read these fails because they're quite detailed. So notice here, on line 14 is where an error happened, where it was trying to check the equivalency of 0 and 1, and it found that's not correct. And the values that it used for that test were 0 and 1. That'll change when we have a function in there. So I failed. I passed 1, as it turns out. The 0 equals 0, but I failed the 1 equals 1. There's another way you can do this, by the way. You can actually get down here in the console. I'm going to type clear and then ls, and let's see if it's here. It is. So you can actually, let's see, so is it -s? Yeah. So if you get down here in the console manually, you can actually see your successes, which is what the -s is doing, in addition to your failures. So you can get in the console and manually execute these unit tests so that you can see both the successes and the fails. If you just click run, you're only going to see the fails and not the successes. But and you'll notice what it did really is /main. So if I do /main, but with -s in there, there's a space, I will see both my successes and my failures, and some people like that. All right, now let's do a slightly more realistic unit test, because these are dumb. Now let's go up here above the unit test section and define a function. So let's just say And I'm going to go ahead and do the whole definition up here above the unit test. So I'm going to return the result of adding a plus b. In fact, I'm not. Let's do it wrong. Let's accidentally say return a plus 1. So the function is wrong. And now how would a unit test expose that? So we would do something like this. Check equals. Well, if I add 0 and 0, I would expect that to be equivalent to 0 as a result. And I'll try a few others. Why is this thing shifting over on me? I don't know. So let's see. Check equal, add 0 and 1 should yield a 1. And I'm going to add several of these kind of around. Why is it doing that? Well, I'm not going to allow it to do that. 1 and 0 should be a 1. Um, 1 and 1 should be a 2. And then finally I'll do a negative 1 and a 1 should yield a 0. So I've written 5 tests on this one functional unit, as it were. And notice how I'm sort of all around 0 and negative and stuff. This is not exhaustive, but you'll see when we run it, I should fail some. Well, when it reconnects. Okay, so here we go. I'm going to fail some. I put an extra comma somewhere. Okay, so I'm failing. I'm failing 2. So if I want to, I can say /main-s. By the way, for those of you who are here, thank you for that. But guaranteed there's going to be people who'd never watched this lecture video and say, how do I see the successes? Pretty much a guarantee. So you're in the know if you were here or if you're watching the video later. But you will have classmates who don't watch and then will ask this question and it will seem quite dumb. Okay, so I can see my 3 successes. Which ones? So something's wrong when I add 1 and 0. Oh no. When I add 0 and 0, I'm actually getting back a 1 from that. That don't make any sense. The other error, when I add a 1 and a 0, I'm getting a 2 back. That doesn't make any sense. So the first line is the test that's failing and what was supplied to the test. The second line is what tests the test is actually being run against. So in the second line, the values is showing you after the functions have run. So 0 plus 0 is getting 1 for some reason, and 1 plus 0 is getting 2 for some reason. So I know something is wrong with this function. Because 1 and 0, so when A is 1 and B is 0, I'm getting 2. But if I go and I look carefully at this function, I'll notice, oh crud, I put a 1 in there and not a B. That has to be a problem. So I'll rerun it. And now I'm passing. So when you get to this success, that means you passed all the tests. No. So Magenta asked, do I have to reset any variables to 0? I do not. Not in this case. The caller is supplying me with an A and a B, and I just return them added together. And in the tests themselves, I'm not actually using variables, although I can. No, those are good questions to ask, Magenta. Keep asking them, because normally those questions are going to get me to where I can point out, highlight something. So always useful. And then I'm seeing my successes. And if I want all the glory of all my successes, I can say /main space -s, and I can see all the successes, which feels really good. And then also the overall success that all tests have passed. So that's how they work. And these unit tests work a lot easier if we're testing functions that return values or that accept parameters by reference, and then we can check the values of those parameters after the function has run. Okay, so that's a real basic one. Now let's get a scarier one and get the whole lab 3 in here. Where'd it go? Where did it go? Well, I'll just go back here and get it this way. Get it this way. Okay, so here's the full-on scary, the teacher wrote the unit test. So here's all that doc test stuff. So the program somewhere is using strings. I may or may not have that as a worry. All right, so here's the instruction. Complete these functions. So these functions are all set up but have no guts in them. So they're going to have to all be implemented. Here's a void returning function, which is a little weird until we notice that, oh, there's a whole bunch of pass by reference. So if these are to be tested, no doubt the pass by reference variables are going to be tested after this function is executed. And then a couple that return double. So that's the code that you work on as the programmer. And here is the unit test that has been written. So you don't alter the unit test. You implement the functions to satisfy and pass the unit test. But you can use the unit test to get a sense of what it is that you're supposed to be doing if you have doubts. So it's testing the greet function in a couple of different ways. It's testing the isFactor function in a couple of different ways. It's testing the make change function with its own variables, notice. And it's testing the converter functions, which are testing for approximate results since they're floating point. Okay, so all those tests are already written. You don't touch those, which is why it says don't alter. Okay, so what's my challenge? Well, let's see if I press run, does it even run? Not really. It does seem to run to a failure, but I'll also notice that I have a crash. So if the unit testing is crashing, that's a problem that we can address easily, and let's do that easily and first. So the unit test is crashing because these functions that are promising to return values don't even have return statements in them. So the first step that I would recommend, in fact, I will add it to the notes. It's called stubbing the functions. So since it's crashing, let's stub the functions before we try to do anything else. So we find all the functions that promise to return a value. This one a string, this one a bool, this one we don't have to worry about because it's void, this one a double, this one a double, and we stub them. So the way to stub a string returning function is to return a string. Let's just return a nothing string. So this is a stub, meaning the function is actually not doing its job just yet, but it won't crash around it anymore because we are actually sort of satisfying the requirement that returns something. So we're just going to return empty string. Bool. So got to return something. I'll just return false. Because that's a bool. I could have returned true. That would be as good a stub as false. The void function doesn't need to do that. The doubles seems to me, okay, that returning 0 should satisfy the rule and allow it to run without crashing. And then stub out this last one. So that's stubbing the functions so that it won't crash anymore. So now let's run it with stubbed functions and see if it doesn't crash anymore. Okay, it does not crash. It fails a whole bunch of tests. It actually passes some. So let's go down here to the bottom. I'm going to type clear in the console here to clear the screen, C-L-E-A-R. And then I'm going to run main, and let's see our successes also. So we're accidentally, as it turns out, passing a couple of tests just with the stubs. So that can happen. The stubs are good enough to pass to, see, one of the tests, two of the tests, three of the tests we actually are accidentally passing just with the stubs. But of course the stubs aren't good enough to do the lab, so we have more work to do. I'm going to give you, where do you want to see? I'll give you a hint on make change perhaps. So that's stubs. And then what we would do next so test one function at a time. And what I mean by that is really, I should have said it this way, in fact, implement and then test one function at a time. So pick a function and go work on passing its test, like make change. I'm doing this to give you a hint about how this one works. So I need to notice that there is an initial value. So, and it's passed by value, meaning it's just going to be some kind of number of pennies, if you will. I will also notice these are all unsigned, which means that they are all positive numbers, 0 or positive. They can't be negative. All right, so that's fine. Okay, so how do we do this? I'm just going to get the nickels out to show you how this can work. So I'm going to take the pass by value nickels parameter. So I'm about to overwrite the original variable that I now have a sense is coming in from the unit test, but that's what's expected. So how do we get nickels off this initial value? Well, I can take the initial value. I can scrub off the quarters. So if I take an initial value and mod 25, that tells me how much is left after the quarters are out. So take 99 cents as an example. If I mod 99 by 25, I get 24. That's what's left. So this means what is left after I take the quarters out in this context. So you may need to think that over a little bit, but this is one of the uses of mod, is to sort of get the leftovers. So what's left over after I take the quarters out? I also need to take the dimes out. So in the case of 99, we'll do a different value. If I take the quarters out, that leaves 24. If I take the dimes out of the 24, I have 4 pennies left, which would be no nickels. But let's say that I had, let's do the easy one, 41 cents. So if I do this part off of 41, I'm left with 16. If I do this part off of 16, I have 6. And then I need to know how many nickels are there in that. So now I switch to the divide sign because I need to know at this stage how many nickels are in the initial value once the quarters and also the dimes are taken out. I don't return anything because this is a void returning function. So I simply overwrite the by reference nickels, and what should happen at this case is that I hope anyway, that I will pass a new test. And I'm going to go down here, Claydar, clear. Go down here and run this with the successes option. So here's one that has nickels in it. And I'm passing 1, 2, 3, 4. So I'm passing this nickels one that I wasn't passing before. I'm also passing this nickels one, which I think I was accidentally passing before. But now I've added nickels into one of the tests that I am passing, and I am on my way. So the next step would be to do the quarters, the dimes, and the pennies off of this, which hopefully that's enough of an example for everyone to work with. Celsius to Fahrenheit, if you don't know it, Google. Fahrenheit to Celsius, if you don't know it, Google. I don't need to take time up out of your day for those things. Okay, so I didn't do very much code. So I showed the stubbing and I showed the nickels part. I'm going to leave it there on the video. I'm not going to upload this because there's nothing really to upload that you can't get out of the video, I think. So I will upload the other samples that show all the different functions and the bad and the good function and stuff. But this one, I want people to be watching the videos anyway, since I take the time to make them. And this isn't enough code to bother with a whole upload anyway. Okay, so that's it. If you were able to be here, thanks. I hope for the rest of your Labor Day goes well. If you're watching this later, I hope you have had a good week of Labor Day. For those of you who happen to have something that you get to do or get to not do on Labor Day, then I hope that went well for you and that was enjoyable. Thank you, Magenta. You have a good day as well. And I will see you guys on... I did not talk about the first project, so that needs to happen pretty quick. It is due October 2nd. Okay, we're okay for me to put that off. You should go look at project 1, but I think I'm okay to leave it for next time, and maybe I should put it first, so I'll try to make a note to myself to that effect. Okay, you guys are all graded up, so all your labs are graded, and just about everyone did good. And I picked at everybody a little bit just to get us all being consistent. You don't have to use my style, but pick a style and be consistent with it. If you found that you're struggling in an area, please take advantage of the channels that you have to get help. Piazza, me and your classmates. Scheduled office hours, me. Open office hours, me and potentially your classmates. Canvas inbox, me. So there's lots of places for help. And it's better if you get to that before the weekend, because I don't check my inbox very much on the weekend because that's the weekend. Okay, so D. Hawkins, you have a great day as well. Thanks for hanging out, and I will see everybody next week. Be good.